Today I'm going to talk to you about the different types of microscopes and compare them to one another. First, I want to talk about the optical or the light microscope, which will be the type of microscope that you'll be most used to and you'll have used in class before. The light microscope uses light to view an image, and an advantage of this type of microscope is they're relatively easy to use, and the specimen that you view underneath it can actually be living, so you can actually view things that are living and moving. An example of this is the water flea or Daphnia. You can observe it under the microscope, you can see its heart beating. The maximum useful magnification of the optical or light microscope is about 1500 times what you can view with the naked eye. So there are some limitations to that, and the first is the organelles that you can view. So you can possibly see the mitochondria. Mitochondria, you'll be able to see the very, very faint detail, if at all. You can see the nucleus, because obviously it's a fairly large organelle. So the nucleus, you probably will see that very easily with the light microscope. However, the mitochondria, not so easily. The resolution of the light microscope is approximately 0.2 micrometers. So the resolution is how detailed the image is, also how we can distinguish between 2 points on that image. And because of that, we can't actually view anything smaller than 0.2 micrometers. So anything like a ribosome or the endoplasmic reticulum or lysosomes can't be viewed under a light microscope. The next type of microscope we're going to talk about is the electron microscope. Now, there are a lot more uses to an electron microscope, and that is mainly because of the fact that you use electron beams to form an image. Now, a disadvantage is you can only view dead samples, so they have to be fixed in a medium and they have to be put into a vacuum, so they can't actually be living, so you can't observe anything living under an electron microscope. An advantage, though, is you have a much higher resolution than a light microscope. Now, it's around 1,000 times greater, and you can view objects up to 0.0002 micrometers across. You can view very, very small organelles. That allows you to see much more detail and much more organelles using this type of microscope. Now, the useful maximum magnification of an electron microscope is about 1.5 million times magnification, so 1.5 million times what you can see with the naked eye. There are two types of electron microscopes you have to be aware of. The first type is the transmission electron microscope, or the TEM. Transmission electron microscopes use electromagnets, and these will focus beams of electrons onto and through a specimen. Now, the specimen itself is set in a resin, and that means that when the electrons pass through, what will happen is the parts of the specimen, so certain organelles, will absorb more electrons, which will make them appear darker on the image. Now, an advantage of being able to focus these electrons through the image is you will have a very high resolution, and you'll be able to see organelles in a lot of detail. That includes their internal structures as well, so you'll be able to see the internal structures of things like chloroplasts and also mitochondria as well. Now, to be able to allow you to see the image and be able to allow the electrons to penetrate through the image, the specimen has to be very thin. A thick specimen will not allow the electrons to pass through, so the specimen has to be cut very, very thinly before it can be viewed under an electron microscope, the transmission electron microscope. The second type of electron microscope is an SEM, or a scanning electron microscope. Rather than firing a beam of electrons through the specimen, it will allow, like the name suggests, it allows the electrons to pass over in a beam. Now, what that does is when the electrons hit the specimen, they will actually knock electrons off the specimen itself. These then are then gathered in something called a cathode ray tube that then forms the image. But as you can probably can imagine, because the electrons pass over the specimen, this means that the image you get isn't internal structure, it's only the external structure. However, because the electrons pass over, they can form a full 3D structure. Having said that, they do have a lower resolution than the transmission electron microscope, but an advantage is that we can use them on thicker specimens because we aren't passing electrons directly through the specimen, the electrons are passing over the specimen.